If you didn't watch the last video, don't hesitate to go and watch the introduction. Make sure you subscribe. How do we differentiate using the first principle? Hi everyone, I'm Professor Wilson Kamame. My channel is also called Professor Wilson Kamame. This is our second video on calculus 1, differential calculus. In this time we are looking at how do we differentiate using first principle. So if you didn't watch the last video, don't hesitate to go and watch the introduction to differential calculus. Today we are looking at how do we differentiate this one now using the first principle. So if you haven't subscribed, make sure you subscribe and remember to hit that notification bell for more videos. So let's look at how do we differentiate when we are using the first principle. So in this case, I know we solved just a simple differentiation where we solved polynomials using various rules. We solved all that with our previous video. Today we are looking at the same, but this time we are using the first principle rule. As we agreed, we look at first principle rule before we proceed to trigonometry and the like. How do we differentiate using the first principle? We use this equation where we say the first derivative will be limit as h approaches 0 of our function f x plus h minus function with respect to x over h. So this is key. You must know which formula do you use to solve when you talk of solving using first principle. But you might be knowing the formula, but how do we solve this one? That's why we are here to help you solve various examples using the first principle. So my first example, you are given a function y is equals to 2x. We need to differentiate this one. And we are differentiating this one using first principle. How do we solve this one? So remember, our function is a function of x is 2x. So based in our formula, our f of x automatically is our 2x, but we need our function x plus h. So we need our function x plus h. So whenever we have x, now we have replaced with x plus h. So we have 2, whenever we have x, we have replaced with x plus h. Let that one stick into your head. Whenever you have f of x is equals to 2x, if you are asked, find f of 1, you know we replace where we have x with 1, and you get 2. If you ask f of 0, you know we replace where we have x with 0, and get is 0. So in this case, we are asked f of x plus h, we replace with wherever you have x with x plus h. So it will be 2x plus h. And when you open that one, we will get 2x plus 2h. So now we can be able to get the first derivative where we might use 1 y prime. You can also use f prime of x. I'm just using all these, you can use any. Will be equals to limit as h approaches 0. My function fx plus h, remember, we have gotten is 2x plus 2h minus, after this minus, make sure you use the bracket, minus my function of x, which was 2x, all over h. So with this one, you get it is limit as h approaches 0, 2x plus 2h minus 2x all over h. I know with this one, you can be able to see this one, and this one will cancel out because it is 2x minus 2x. So we will have limit as h approaches 0, it will be 2h over h, which will be limit as h approaches 0 will be 2. Automatically the answer will be 2. Because we are replacing, we don't have h, where we call direct substitution. We shall look at limits later in the day. So limits, we don't have h. If we had h here, we could have replaced our h with 0 automatically. So we have 2, we don't have h, so automatically we get 2. And how we differentiate. That's how we differentiate. So this is what we call the first principle rule. So let's proceed to our example 2. We can talk of y being 2x plus, let's talk of 3, 2x plus 3. We want to proceed solving more and more complex equation. So y is equals to 2x plus 3. So remember, this is our function of x, which will be 2x plus 3. But in our equation, we are required to get f of x plus h, a function of x plus h. So we said wherever we have x, we replace with x plus h. So it will be 2x, x will, now we replace with x plus h plus 3. I know most of the students confused from here. Wherever we have x, that's where we are replacing with the x plus h. Not everywhere. So we are replacing there with x plus h. So we can open this one, we will have 2x plus 2h plus 3. That's our function. Now, we use our formula. Gamma y prime, regardless your function will be given as what? Will be equals to limit as h approaches 0. Our f of x plus h, remember we have gotten 2x plus 2h plus 3 minus our f of x, it was 2x plus 3 all over h. Remember, I said this bracket is very important because if you don't put this bracket, you might find this is minus 2x plus 3. But if you put this bracket, you realize when you be opening our bracket, it will be minus 2x minus 3. So that bracket is key to everything. So now we will have limit as h approaches 0, we'll have 2x plus 2h plus 3 minus 3x minus 2x, sorry, minus 3 all over h. Okay? You know again, 2x minus 2x, that one will disappear. So this one and this one will disappear because it is 2x minus 2x. This one and that one will disappear. So we will be left with the 2h all over h. So limit as h approaches 0 will be 2. Again, the answer will be 2. Our third example, y is equals to x squared, where we have said automatically we know it will be 2x. But how do we solve this one using first principle? Remember, our function is x squared. So what will be our function x plus h? We said wherever we have x squared, assume we added 1, because even if you add plus 1, this is plus 0, we will just get is equals to 2x. So assume it like that so that we get used to complicated equation. We are using first principle. Remember, our function is x squared plus 1. So wherever we want to get the function of x plus h, we replace wherever we had x with x plus h. So that one will be x plus h squared plus 1. So we are replacing x plus h to where we had our x. So it was x squared, it will be this one squared. If it was cubed, it will be this one cubed. So when you open this one, I know you get x squared plus 2xh plus h squared, now plus 1. I know this one, you know how to open a plus b squared. It will be a squared plus 2ab plus b squared. I know that one is simple from here. You know you get a squared plus 2ab plus b squared. With that guidance, you know why we are getting all that. Or you can use the normal binomial expansion. So with this one now, this is our function of x plus h. Remember, our formula when we want to get the derivative will be equals to limit as h approaches 0. So now my function x plus h, remember it is x squared plus 2xh plus h squared plus 1 minus my function of x. What was my function of x? It was x squared plus 1 all over h. Remember we said this bracket is key. So my fx plus h, it is this one plus 1 minus my function of x, which was x squared plus 1. I like telling students, if you arrange your work this way, it is hard to fail that question. Even though you make a mistake, you can be able to trace back where you made that error. But if you don't arrange your work, it will be even much hard to trace where you made that error. Remember, with this one, back in our mind, we know automatically we will get 2x. But how do we solve that one? So with this one now, you can open the bracket. You'll have limit as h approaches 0, you'll have x squared plus 2xh plus h squared plus 1 minus x squared minus 1. Remember, that's why the bracket is important. It is important because when you open, it will change it will have a very big impact when it comes to signs of those functions. So again, this one x squared and this one will cancel out. This plus 1 and this minus 1 will cancel out. So we will be left with limit as h approaches 0. We will have 2xh plus h squared all over h. I think with this one we can separate. We have limit as h approaches 0, 2x h all over h plus h squared all over h. I know with that one now, limit as h approaches 0, we will have 2x plus h. Because this h will cancel out, this h will cancel with 1h. So you have plus h. So again, because we are using what we call direct substitution, you replace your h with 0 because h is approaching 0. So direct substitution, you will get the answer will be 2x. Let's proceed to another example where it will be equals to, we have our function y is equals to 1 over x. So we are required to solve this one using what we call the first principle. So again, my f of x is 1 over x. My f of x plus h is 1 over, remember we are replacing wherever we have x with x plus h. So it will be 1 over x plus h. Now, the derivative now will be limit as h approaches 0, fx plus h, it is 1 over x plus h, minus my function of 1 of, it will be 1 over x, all over h. So we are solving this one. We have replaced fx plus h is that one, and f of x is that one. So I know you are wondering why I have not put the bracket, because this time it won't have any impact because we don't have addition or subtraction. It's just one function. So how do we solve this one? There are some people who solve this one. There are various methods of solving this one. Remember, this one is just like a function. A fraction. We are solving two fractions, 1 over 2 minus 1 over 3. It's just a fraction. So how do we solve fraction? There are some people who multiply directly with the LCM. So you multiply with the LCM. But I would like to solve this one alone, where you have 1 over x plus h minus 1 over x, where the LCM is the product. So when you take this one, divide this one, you'll be left with x. So 1 times x minus 1 times what? This one divide this one, you are left with x plus h. So when you solve this one, you get x minus h all over x plus h. This one will be minus h all over x plus h. This is like you are solving a fraction. So with this one now you have limit as h approaches 0, we will have minus h all over x plus h. That is our numerator all over h. Yeah, there are some people who will multiply this one with the LCM. The LCM of this one and this one is x plus h. Then they will multiply here and here with that one, the way we have solved that one. Let me say it is just like you are solving 1 over 2 minus 1 over 3. You get the LCM is 6. 6 divided 2, you get 3 times 1. 1 times 3. Minus 1 times what? 6 divided 3, you get 2. So it's just like we are solving that one. I prefer to use that one, which is very simple and very basic for a primary student, so that at least they can stick into your mind why we are getting this one. Again, simplifying this one, remember you have numerator and you have denominator. I think the h will cancel out. We will be able to see that whenever we are solving this one, we can multiply numerator and denominator with 1 over h. We can multiply with 1 over h and denominator again with 1 over h, so that we will get limit as h approaches 0 will be negative 1 all over x plus h all over 1. I know the denominator will be all over 1. There is no need of writing that one. We have multiplied with 1 over h, so that this h and that one will cancel, this one and this one will cancel, will be left the denominator is 1. So it is equals to limit as h approaches 0 will be minus 1 all over x plus h. And now, with the direct substitution, when you replace h with 0, you will get is minus 1 all over x squared. And that's the derivative of 1 over x. So, regardless of whether you are using the quotient rule, whether you are using the first principle rule, the answer will be the same. We said we will be making the equation becomes a bit complicated as we proceed. So now, my example, we have y is a third equation, root of x. So you are required to solve this one. Remember, the procedure is the same. My function of x is this one, root x. So I need f of x plus h. So I just replace whenever I have x with x plus h. Wherever I have x, I'm replacing with x plus h. So now, my first derivative will be limit as h approaches 0. Fx plus h, now it will be root of x plus h minus root of x all over h. Because we are replacing fx plus h with this one, f of x with this one. So this one minus this one. There's no need this time of, or you can put, but it won't have any impact, that bracket. So with that one now, we can be able to solve this one. Now the issue is, how do we solve this one? As you can see, we are dealing with the sand. If you want to eliminate the sand at numerator, what do? We multiply with the conjugate. Remember, we are multiplying with the conjugate. So we multiply with the conjugate of numerator. So both sides, allow me to use just this space for the sake of my board. So I'll multiply with root of x plus h, but this time plus, because we are using the conjugate. This one was minus, so this time the conjugate of this one, it will be plus. So just as what I have done with the numerator, I must do the same case with the denominator. So that in mathematics, it's just like I have multiplied with 1. Because this one over this one is 1. It's just like I have multiplied with 1. I haven't altered anything with my equation. So when we solve that one, you get limit as h approaches 0. I'll get this one. Remember, when you are dealing with SAD, now when you open this one, you have root of this one minus root of this one. Maybe there are some people who can tell me, if you have this one, root of a plus root of b, we will multiply with the conjugate. What will you get with this one? You will get a plus b. You get a plus b. You get a plus b on that one. So in this case, I'll have x plus h no, it will be minus, because this one we are dealing with SAD. When you open this one, you have a minus b. So in this case, I'll have x plus h minus x all over now the denominator. Remember, I had multiplied with root x plus h plus root x. So now, as you can see here, which of the equation we will be able to simplify out? As you can see, this x and this x will cancel out because it will be x minus h. I hope this one is clear. We have two sides here, this side and this side. They are separated by negative sign. So if you want to eliminate side, we must multiply with the conjugate. we must multiply with the conjugate. And conjugate, we just change the sign. And when we change the sign here, it becomes positive. So whenever I multiply with in the numerator, lazima, at the same time I multiply at the denominator. So in this case, we are multiplying this one over this one. It's just like I have multiplied with one, the conjugate, numerator and denominator. So whenever I open this one, I have explained, if you have two sons, you multiply with the conjugate, you will get root of this one and this one, you get A, but the sign you have minus B. So in this case, I'll have this one times this one, I'll get this one. Whenever I multiply this one with the issue behind this one is that when you multiply this and this one, maybe I can explain further so that it can sink in your mind. Whenever you open this one, you have A. This one times this one, I have minus root A, root B. Let me use that one for the sake of. Then plus root A, root B. Sign will be minus root B and root B, you have B. That's why you see this one is minus and this one is plus. They will cancel out, so you are getting A minus B. So the same case will happen with this one. So whenever I multiply this one and this one, I get this one. This one and this one, and this one and this one, they will cancel out because this one will be plus that one minus this one and this one will be the same. So they will cancel out. So whenever I multiply this one and this one, I'll get X, but the sign now will be minus. That's why I said this one will be minus. So again, when I simplify this further, I'll be able to have limit as h approaches 0, I will have h all over h into bracket root x plus h plus root x. Where I know with this one, you know, because this is just a product, this one, h and this one can cancel out. But if it was h plus this one, it could not be able to cancel out. But the advantage is this one is a product. So this h and h can cancel out. So we have limit as h approaches 0, we have 1 over x plus h, which is a root, plus root x. And now, remember, we are having what we call the direct substitution. We replace wherever you have h with 0 after solving everything. So you have 1 over root x plus root x, where you have it is 1 over 2 root x. And that's the answer. So now, having solved all those examples, you can go and try to solve these examples. You try to practice and see if you can be able to solve this one using first principle. That will be the end of our today's class when it comes to how do we solve first principles. If you have a question on first principles, you can reach me with one of my channel, ask the question, I'll be able to answer. And don't forget to subscribe so that whenever you have a new video on the same, you can be able to proceed as a class together. So this is my second video. You can wait for the third video, and I'm happy. Thank you for everyone for watching.